this great performing solution. The problem is when you have this broad range of APIs, how do you get them all right? You know, Microsoft isn't going to give us the source code to their get message loop and the create Windows loop, and what order do the messages get actually generated, which is not specified. So the lack of specification made this an incredible challenge. So we had great performance, and as a result, we ended up restricting the number of applications to the personal productivity applications that were necessary, that were in demand at the time for Unix workstations. Microsoft Office was the #1, and there were other suites available. And we, through rigorous testing and macros, automated testing, we were able to get the compatibility up sufficiently for a product. But unfortunately, we couldn't just run every single off-the-shelf application. So the core technical challenges, and most of these are in device emulation. For DOS emulations of, prior to Windows, VGA emulation was one of the killers, because it's not simply trap an I/O request and translate it to something in the native world. We didn't have comparable hardware on a Sun workstation. We had pretty, flat frame buffers and multi-plane frame buffers. The VGA emulation, basically, when we did an I/O write, we'd actually change and do an arithmetic operation on 2 or 3 planes. So you'd have to translate that one I/O and then trap every memory write to the video plane, and then do a conversion, and then finally blit it to the screen. So performance suffered. And I talked a little bit about protected mode emulation. On the x86 box, that was tough enough when you had the similar hardware. Trying to do a protected mode emulation in a simulated environment where you actually have to simulate every single I/O protection trap, etc. So another common theme is the trade-off of trapping time versus the hardware cost. Where do you put the hardware? Do you put it on in physical hardware in the co-processor days, or do you move it into the simulated world? In which case you start to take the performance hit. For CPU translators, common problem. In Wabi, we had great performance once you got that Microsoft Office application totally translated to the native ISA. But again, our startup time was poor. Even though most of the operating system, we'd boot up our application and we'd have native versions of all the graphical kernel subsystem user.dlls, but the megabytes and megabytes of Microsoft Excel and its VB interpreter getting translated took some time. So it took up to 10 seconds to get the application finally displayed on the screen, which was a problem. And another similar problem with today is large memory footprint, all that bloat from translated code. We didn't have. We had a similar concept to hotspots. Find the basic blocks. We didn't have an interpreter in Wabi. We decided to go right to a 2-phase JIT, quick JIT to just generate code on the fly, so we could throw out initialization code, and then we had basic block counting. So our code buffer got quite large when you were trying to translate these applications. So here we are today with Java virtual machines. We've added new features, new problems for me to solve. We have garbage collection, and we're now multi-threading is built into the language, and synchronization primitives are now built into the language. And these 3 problems have had a lot of research. The benefits, of course, we now have cross-platform portability. We know what the API is. We see the source code for the API. We don't have the problem of it's somebody else's ISA and someone else's API. We don't quite understand compatibility. We now have security built in, and we have scalability, and that, we've defined the language to be scalable. We've had a lot of successes in solving these 3 problems. The synchronization problem, trying to speed up uncontended locks and contended locks, and trying to not do synchronization if you can clearly determine that this code is only executed by this one thread. Garbage collection, there's been a lot of research and a lot of product implementations with various techniques to do parallel collection, to shorten the time it takes to do a collection, to do concurrent marking and sweeping so that we can actually do some work and take advantage of those thousands and thousands of threads that programmers don't know how to program to. And code generation quality has gotten considerably better over the years. So, although those challenges are still important and a competitive advantage for all of us VM vendors, there are other challenges that we see in our group when we're talking to customers. We spoke to a large customer who said, I'd give back 10 or 12% if you could just say, I want it to run for years and years and years. I don't want to have to worry about all of a sudden I hit this one blip. Oh, 10 minutes, okay.
Can you clarify when you say for years and years on any platform or what?
They want to deploy their application server with Java VM, Oracle database, or whatever database, and they want this application to just be bulletproof. I don't want to have to worry about failover and switching off to another VM. They want just absolute reliability. They don't want all of a sudden this one method gets compiled or it blows up because we've inlined this one thing that we never got to test because we didn't run this long before. They want reliability.
But also reliability means if one of your platforms goes down, you can just, run it somewhere else.
There are lots of techniques to do redundancy, but still, if you have a platform that runs for 2 or 3 days and when it blows up, it's still not the best solution for these customers. So I want to just cover a few quick things, given I only have 10 minutes here. Startup, it's been a problem in all the technologies I've worked on. And it's still a problem today at least for clients, but even so in the application server when bringing in another enterprise Java bean, they want it to run right away. We've been doing various things, and here are some techniques that we're looking into for future versions of the VM. We've done some deferred initialization in Tiger 1.5 and have sped up startup considerably for client environments. We've reworked the class file somewhat in 1.5 to make verification go faster. This seems to be slowing down startup. If you do turn off verification, you'll notice things start up quite a bit faster. We've done some class data sharing, which helps the second time you bring up an application because we're sharing a lot of the read-only heap that is in memory from the first instantiation of the VM. One of my personal things I'd like to see our compiler team work on is caching compilation decisions. So it doesn't take us to that 10,000 times to run that loop and then decide that I'm going to inline this, and this. Let's just do it right away and not go through the de-optimization and the uncommon traps and all that overhead. I'd love to see us get to the point where we don't need an interpreter anymore. Wabi seemed to do a halfway decent job. We still had the startup issue. So solve some of the startup issue by maybe caching the class initialization has been determined it only has static fields in it. Like, let's just write that out and bring it in. Save, that's really what the interpreter does most of the time when we're bringing a VM up. We're looking into multi-tiered compilation so that we have a fast JIT and a more expensive JIT. The jury's still out on how much that's actually going to benefit us. In our labs and in our ME product, we have multitasking VMs, which allow us to actually run a second application within the same VM so that you're sharing. That's the ultimate sharing of compiled code, class data, and all the constants and symbol tables, etc., and initialization of the operating system. It's all done the first time. Other things that we need to look at is observability. What's going on? All of a sudden, my transactions per second have dropped to 4 instead of 10,000. What is going on? You have these various layers. Where in 1.5, we've added in the VM management API so that we can look in and see what's going on with garbage collection and heap utilization. And we tend to try to expose these things to the layer above us. But if you have a management app that's just looking at the top, he has a very restricted view of what's going on. We need management applications to see not only the global view, but be able to drill down into these, have some consistent way of presenting the data so applications so that we can determine what's really going on in the system. You know, there's so many layers in this thing, it's hard to try to pinpoint what is causing this slowdown. In 1.5